Okay, you can watch this if you like. Cool. All right. So the first one, and of course, if anything's wrong, please let me know. If anything seems off. But I think these are right. I don't know. So yeah, it's just substitute. I mean, it's pretty straightforward. And that turns into a quadratic. So you guys should be pretty comfortable solving the quadratic. So you have that. Hope you guys are cool with that. Because you still want to be good with algebra skills, right? Solving quadratic functions. Of course, sine theta equals -5 is extraneous. We're not even deal with that. Sine theta equals half. And remember, we're solving from 0 to 2 pi because you're told to do so, right? 2 pi not inclusive, 0 inclusive. And yeah, you get pi 6, 5 pi 6. You get the radius. All's good. Perfect. Good. That makes sense. Okay, awesome. Next one, again, substitute. That's really easy. Of course, everything goes away. I didn't show the graph, but if you were to graph these, one is a cardioid. The other one's like, I don't know what the heck. That's a dimpled limicon. I can't remember, but they don't touch. These won't touch. So don't worry about it. They don't touch. And I will ask you guys to graph these on the test, but you'll have Desmos or a graphic calculator. So you don't actually have, not the whole time.
Those would be the one problem with the guy.
Correct. I'm going to talk about that in 5 minutes from now. I'll get there in a moment. For 3, pretty easy. Tan theta equals that. Solve for theta happens. That happens there. Easy peasy. Work it out. Get the R values. So you have that. That's pretty straightforward. Yeah, that seems to be a-okay. For 4, 4 is a little crazy. I think, do we have that on the whole, on the notes? Well, that looks awfully familiar. Or maybe this someone in class. Did I do this to you in office hours or?
Yeah.
That's was okay. It was you. Yes, and some other people too. Yeah. So, questions on this one. This was a little more complex because you have and again, I didn't show the graphs, but you have 2 Rose curves. Obviously, the orientations are a little off, but one's like symmetric about the polar axis, one's symmetric about theta equals 5 and 2. So you have those kind of symmetries happening there. Actually, is that right? Is it? I think the symmetry. Actually, no, that's not. Anyway, I don't want to worry about the symmetry right now, so that's okay. But regardless, you have 2 types of Rose curves where the orientations are off a little bit because one's sine, one's cosine. You have those points of intersection. And remember, the graph is not reliable, right? Because it might deceive you. The algebra is reliable. We rely on the algebra. So a question on that one. And remember, to always do the 2 pi k bit whenever the coefficient of theta is not 1, because you have like multiple possibilities from 0 to 2 pi. So you want to be mindful about that. For 5, here we have another Rose curve with look like a circle. You have to use double angle. I will provide double angle. Don't worry. I will provide that for you guys. So double angle, and then you can factor, work it out, get those possibilities. And then lastly for 6, a lot of things going on there. That's kind of a crazy quadratic. Work it out. You guys know a factor, find the possibilities, and you have all that stuff. And when you do 2 pi k divided by 3, you have 2 pi k over 3, which is 8 pi over 12, or no, make it 6 pi over 9. There we go. Yeah, make it 6 pi over 9. Good. All's good there. Okay, no problem. Okay, cool. All right, so homework goes okay. All right, so number 6. Sure, this one here. So after you substitute, you're treating like a quadratic. So you factor like you would a quadratic. And you could discard cosine 3 theta equals 4, because that can't happen. But cosine 3 theta equals -1/2, that can happen. 3 theta equals inverse cosine of that, which is 2 pi over 3, or it could be 4 pi over 3, right? So the left half, sorry, of the unit circle. And always put plus 2 pi k before you divide by 3. Once you've done the inverse cosine, put the plus 2 pi k bit. But once you do that, then you divide by 3, and then you have, 2 pi over 9. Oh, but also 2 pi over 3k, right? Which is 6 pi over 9. And so do all these iterations like, oh, let's make K1, so make K2 until you get past 2 pop. We get past that. The R values, once you know the R value for one of these, it should always be the same, at least for that subset. And the other subset, same thing. The graph will actually help if you did see the graph, but I didn't. Yeah, I got kind of lazy there. I didn't do the graphs. So, and obviously this is my handwriting because I couldn't find the previous solution keys for this, so I had to make my own. So hopefully you guys agree with me, agree with my answers. No, okay, not contesting anything. Okay, good. All right, let's talk about the test. So I just typed this up. If I have any typos, I can fix it. So finer details about the test. So it's in Schoology under the assignment major test number 4, 60 minutes. So 60 minutes, you get an hour. Take it tomorrow. Form sheet is provided. I got handed that to everybody. Form sheet looks like this. It's pretty nicely organized, I feel. Some difference formulas, you might need that for proving symmetry. The double angle identities, you guys should know how to derive that. I'm not going to give that to you in the final exam, but for sake of this test, so you're not spending too much time doing that. So I'm trying to save you guys time. You totally could, I'll just give that to you. You won't need, actually, do you guys want unicircle? It might help.
I mean, take it.
Okay, not fill that one though, a blank one. Sure. Okay. All right. Okay. Okay. Then thank you, Charlie, for sharing that. Okay. So yeah, fine. I'll do that. I'll give you guys blank unicircle as well. I'll print lines. That's no problem. Remember, cosine theta has a couple of variations. Test for symmetry, that's provided. Don't worry about that. Just make sure you understand what it means. If you want to be theta about the polar axis, theta equals 0. If you replace it with negative theta and you just get r coming out, great. You're symmetric about that because cosine will be symmetric about r equals theta equals 0. Or if it doesn't quite work, if it doesn't really provide any conclusive results, then you may have to replace theta with pi minus theta. And if you get negative r, then cool. Then it's symmetric about theta equals 0. You have the reverse for theta equals pi over 2 symmetry. In pole symmetry, you're actually replacing r with negative r. And if theta stays unchanged, cool. Or you could replace it with theta plus pi. If r stays unchanged, cool. It's symmetric about the pole. What will help is to actually see the graph and see the symmetry. Oh, okay, I see the symmetry is happening here. So now I know what to have to verify. So you go into that verification process. All the conic stuff I provide because we are going to have something that will involve conics. So I figure I should provide this to you. So you'll have this as well. Now, what am I asking? Here's what I'm going to ask on the test. Okay, so 60 minutes form sheet. It's attached right to the assignment. 2 parts, non-calc, calc. The part 1, non-calc, will be one question will be worth 10 points. And by the way, 60 points total also. So 60 points total, but it scales up to 100. So it's the same way as all of the tests. I don't make any test more or less weight than anything else. Every test has the same weight as it should be because I think the trig one actually should be worth more, but that wasn't your worst test. I won't do that to you guys. So anyhow, they're all the same weight because the trig test has so much more material, but it's okay. I'm gonna ask you Grapholimicon. Grapholimicon. I kind of tell you right now, like I'll probably ask you where does it start? I'll have you do some symmetry, where are the zeros of it, like things like that. What you want to be mindful about is how to create that inner loop and an outer loop. That's what you want to be mindful about. I will give you a table that's partially filled out. I'll advise you what values to plug in for theta to make it easy for you guys. And you just fill out that table, plot the points. And so it's just more just practicing graphing. So you may want to practice graphing limicons on the review pack. I'll show you where you can do that. Maybe if I find some delta math that might help, I can do that too. But I just feel like you should at least do one of these by hand. And I'm telling you what it is. It's a limicon. So that'll be 10 points. And the rest is calculate. And I'll allow Desmos as well. So you go out the lockdown browser. That's okay. You could do the lockdown browser for that. Or you could use your graphic calculator. Expect one question consists of 4 parts. There'll be a parts A, B, C, D. And there'll be multiple choice questions. So I kind of lied. It's not really 5 questions, it's actually 8 questions because there's 4 multiple choice. But they're going to be pretty brief. One will be easy, one will be medium, 2 will be difficult. I'm going to tell you right now, 2 will be difficult. These can span any topic we covered this semester. I do need to do that because I do need to have our tests somewhat cumulative. I do that in geometry CPM. I do it in algebra 2 CPM. I have not done it in this class. I need to start doing that because we have a final exam in about a month from now. So it could be a trig question, it could be a function question, it could be a conic question. Obviously, I'll put a polar question, but anything's fair game. So just so you know, anything's fair game. So be prepared for that. If it helps, I could provide some multiple choice questions. I could provide some samples, so I could do it for you guys. Not a problem. Um, but yeah, do expect that. I could actually create that while you guys are doing some practice. I could do some snapshots of some other questions. So I can do that for you guys. What the next one should be pretty straightforward. Expect one question consists of two parts to be part A and part B. You're converting a rectangular equation to polar form, just like we had in the notes last week, where we had these rectangular equations put into polar form. So that shouldn't be too hard. Just two parts there. Another one will be a system of polar equations, just like we had in the homework. Essentially find actual points of intersection. The algebra will be slightly challenging. What I mean by that, I'm not going to give you something like that's too easy. I'm sorry. I'm not going to do that. That's way too easy. You guys are better than that. Maybe something like 4 or something like 6. Because the other algebra is a little more challenging because you have to do a factor in a quadratic where the leading coefficient is not 1. So I think something like expect something like 6. So I'll have that. Um, Converting an equation from polar to rectangular form, also what we did last week. Then write it as a conic in standard form, and then find some details about the conic. Like maybe I'll say, hey, here's like a polar equation. It's a hyperbola. Write it in rectangular form, then put it in standard form afterwards. And you have the formula sheet, so don't worry. But then I say, oh, then find me the distance between the two foci, or find me the location of the vertex, or the center, or whatever, something like that. Um, so you'll have a question like that. And then one will be like the homework quiz. Analyze a rose curve. Analyze a rose curve. And I'll say, find me symmetry, zeros, things like that. It'll be very, very similar to what we did. But you'll have a calculator course, and you'll have Desmos if you want it. So pretty straightforward. No surprises, kind of. I mean, the multiple choices might be a little surprise. But just in the multiple choice, I'm going to make it worth each one worth 3 points. So 12 points total. So if you just randomly guess something, I'll give you a point. Cool. But then you need to back it up with an explanation or some work to get 2 extra points for that. So so that yeah, so expect that. So yeah, there's a test. Okay. Now you know what to expect. Now I gotta go write it. Um, this packet here, some of the stuff is kind of too easy. Like I'm not gonna ask you a question like number 1, 2, 3, 4, 4, but I could ask something like number 5. That I could do. Um, that's too easy. That's too easy. It's good practice though. It's good to practice. But you have a bunch of like converting equations here, which is good. Graphing. If you want to practice graphing, I think that's good. So you got that. Um, so I think that would be good for you guys to practice graphing. Um, these are good questions. I should ask this. That's okay. Maybe I'll do it for the final. We have to write the equation of a polar function from the graph. That's okay. No, I kind of like it though. It's okay. Symmetry. It's good to practice symmetry here. So you can practice symmetry here. Solving. Yeah, solving. This is good. We're going to do this stuff in the next unit, just so you know. 2022, I crossed it off. We'll do that stuff in the next unit with complex numbers. Those turn out to be pretty fun. You have all the answers here. I guess from some website last year. Person seems to be the authority on pre-calculus honors type stuff online. Um, then they have some old tests from like prior years. So yeah, you have this right here. Given this, answer questions about it, blah, 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 go through it all, find the zeros, all that fun stuff. Yeah, where this is asking. What portions? Wait, what is this asking? Or two portions? Oh, okay. Oh, how do we generate got it? Okay, got it, got it, got it. I see. This one here, yeah, get those points. Okay, that's kind of cool. That's a good one. The answers are located on the next page. Don't worry about 6. Wait, 6? Is that good? That's kind of crazy. What? What's going on 6? Hold on. It's good practice. I'm not gonna ask that. Whoa. The 6 pi? Why did we do that? This is from a prior to, it's not me, just say no.
A lot of these are notes, no physics.
Maybe you might be right. It's good practice. Okay, whatever. Um, I'm not gonna ask that. That's crazy. I don't want to grade that. Um, this is parametric to parametric. Converting. So like I was saying, like converting a rectangular, sorry, pole to rectangular. Yes, definitely I'm gonna ask them like this. Definitely. So that's good. Converting from a rectangle to polar, definitely gonna ask this. That's good. Analyzing, definitely gonna ask that. Um, solving system, definitely gonna ask that. Save that for practice. And then the answers are all there. And I think that kind of covers. So you got plenty of practice here. So work through it if you haven't done so already. Yeah. So that's what's going on. What I will do is I'll see if there's any good Delta Math stuff while you guys are working. I'll also generate some multiple choice practice because it's a decent portion. It's gonna be 12 points out of 60, so a fifth of the test. So want to make sure you guys are prepared for that. It's also just kind of just guys thinking about multiple choice in general for AP calculus, which you'll do, next year. And for those who might be toiling around, anyone doing the SAT this coming Saturday? You are? Yeah, see, there we go. But they don't do polar, by the way. They do trig, some trig. Um, yeah, anyhow, let you guys get to work.